Okay, this is a little bit of a long video that we're going to be doing on motion graphs. Okay, so just keep going with it. Okay, so from distance time graphs, we can not only find a position at any given time, but we can also see what's happening to the particles or whatever we're doing. We can also look at velocity, and acceleration. So we can find a position, but we can also find a velocity and acceleration. So copy that and come across. So here's an example. So let's have a look, make sure you can read what the graph's happening. So x, I'll just cross off that t. So x is being measured in meters, okay, and t is being measured in time, okay. So this is particle moving, so time equals 0. So we can't have anything going backwards because time doesn't exist backwards. So the particle starts at position A, so its initial position, okay, that's its initial position. So its initial position is A, and at some time x, the particle has moved from A to position B. Okay, so the change is uniform. So the positions change is uniform. It's a straight line. So once you see a straight line for position, that means the velocity is a constant. And then once you see velocity is a constant, then the acceleration must be 0. Okay, so a straight line for x. A straight line for x means the velocity is constant, and if the velocity is constant, then the acceleration is 0. Now what's the particle's velocity? It's just the change in y, so b minus a over x. So the particle's velocity is change in position over the change in time. Okay, so copy that and come across, and we'll look at a couple more examples. Okay, let's have a look at this one. So let's have a look, see if we can fill in. So the particle starts at position A, okay? Now, x is not a straight line. It's increasing at an increasing rate, so it's getting quicker. So the velocity is increasing, okay? If the velocity was constant, it would be a straight line. This one's not a straight line. So if the velocity is increasing, if the particle is getting quicker, then the acceleration must be a positive number. Okay, it's not slowing down, so that means it's accelerating. Okay, so copy that and come across when you're ready. Okay, so let's have a look at another change. So x, I'll just cross off x. Oh no, x is being measured in meters, sorry. X is being measured in meters, t is being measured in time. So where does the particle start? The particle starts at A. From t equals 0 to t equals x, the particle's velocity is decreasing. How do I know that? The answer is the gradient is a negative number. Okay, the particle is slowing down because the gradient is negative. At x equals 0, the particle is stationary. Stationary, if only just for an instant, so it's an instantaneous stop. And then for t this way, the particle's velocity is increasing. Okay, so up here we could then go back and say, well, the acceleration is negative because the particle is slowing down, and now we can say here the acceleration is a positive number. Okay, so if the velocity is decreasing, the acceleration is negative. Okay, copy that and come across. Okay, so now we're looking at a different type of graph. Rather than having distance, we're actually measuring velocity, and velocity is measured in meters per second or kilometers per hour, and here is time is in seconds. Now this is, note, velocity, not speed. Okay, different things. Okay, so this one here, this first one is a constant velocity equal to a meters per second. So therefore, if the velocity is constant, then the acceleration is 0. Now this obviously is a positive number, so therefore the particle is moving to the right. Okay, so we're moving to the right. Now down here, okay, it's a constant velocity of minus b meters per second. Its acceleration is 0, and this time the particle is moving to the left. Okay, so this is a negative number, which means that the particle must be moving the opposite direction. Okay, don't mix up speed. Okay, these numbers A and B could both be the same number, and so the speed is 60 meters per second, but one is moving one way and one is moving the other. Okay, copy that and come across. Okay, so let's have a look at some questions for this one. So what's the particle's initial? So we're measuring V, and we're measuring, oh sorry, I didn't put time there, and let's just say it's in seconds, okay? If that's in seconds there, then that has to be seconds there. So what's the particle's initial velocity? So at t equals 0, the particle is moving at minus 3 meters per second. Okay. When the velocity is 0, the particle comes to rest. So the particle is at rest at t equals 2 seconds. And the last question I'm going to ask is, what's the particle's acceleration? Well, acceleration is the change in velocity. So the particle's velocity has increased by 8. It's gone from minus 3 up to 5, and the time frame is 5 seconds. So the particle's acceleration is 1.6 meters per second squared. Okay, copy that and come across. Okay, so let's have a look at the last question, which is going to be a long one. A particle is moving in a straight line. They always move in straight lines. In year 11, the initial velocity is 10 meters per second, and it has a constant acceleration of minus 2, which means that it's decreasing. Okay, the particle's velocity is decreasing. Okay, sketch the velocity time graph. So most of these times, you want to sketch the graph. Even if it's not asked to do, you want to sketch the graph and see what's happening. Okay, so sketch the graph, describe the particle's motion during the first 8 seconds, find the total distance travelled, and find the displacement. So total distance and displacement are different things. The displacement will be based on a change in position, whereas the total distance is the total distance. Okay, so actually, I'll let you have a crack at it first, and then see how you go, and then we'll see what we've got. Okay, you're back. Okay. V meters per second. Seconds. So it starts at 10. Okay, and it's going to decrease, okay, at a constant rate. Now, it doesn't say how long to go for, so we just need to find this value here. Okay, so if it's decreasing at minus 2 and it starts at 10, that means it's going to be 5 seconds there. Okay, and then because these other questions ask it about 8, let's put 8 seconds in. Okay, and then 8 times minus 2 is minus 16, so it's going to be at minus 6. Okay, so that's the first part. Describe the particle's motion. Okay, so this is going to be a bit of a story. So from t equals 0 to t equals 5, particle is slowing down. But it's still moving to the right. Okay, because the velocity is positive, it's moving to the right. At t equals 5, particle is stationary. Particle is stationary just for an instant. Stationary just for an instant. Okay, and then from t equals 5 to t equals 8, particle increases speed, but going in the opposite direction. But in opposite direction. Okay, so at that time it's 0, and then it's going to increase to 6 meters per second, but it's going in the opposite direction. Okay. C, find the total distance travelled. Well, the total distance will be the area there plus the area there. So that'll be the total distance travelled. So So total distance. Okay, in the first area it's a triangle, so it's half times base times height, so that's 25 meters. In the second one it's a triangle again, so it's half times 3 seconds times 6, so it's 9 meters. So the particle has moved 34 meters. Okay, so that's total distance, but the displacement will be where it's come from and where it's ended up. So that's part C. Part D, okay, so the particle went 25 meters in one direction and then it's come back 9 meters the other way. So the total displacement will be, it's gone 25 meters in one direction, but then it's gone 9 meters in the opposite direction, so the displacement is 16 meters. Okay, that's it. Thanks. Bye.